Hey everybody, welcome back to Mr. A's Geometry course. Today we're going over section 6.5 of geometry, which is all about inequalities in one triangle. Let's get into it. As a reminder, an inequality is when we have things that are not equal, but instead less than or greater than. The first inequality we're going to learn about is the triangle longer side theorem. And even though the name of this theorem talks about sides, this theorem actually gives us information about the angles of a triangle. So if we know the length of some sides in a triangle, and we know that one side is longer than another in a triangle, then the angle that is opposite of that longer side is going to have to be greater than the angle across the shorter side. Right? So the angle across from a longer side, it will be more degrees than the angle across from a side that is shorter in that triangle. So here's a triangle with three known side lengths, right? And there's a little inequality that's written right here for our side lengths. Side CE is the longest side, which is therefore greater than EJ, which is the second longest side, which is greater than CG, which is the shortest side. And what we can tell from these side lengths is also the order of angles from largest to smallest as well. So our largest side, CE, the angle that is opposite of it would just be the angle that doesn't touch this side. So we have C and E as our endpoints. J is the only other vertex that doesn't touch this side. So angle J is the angle that is opposite of this side. And because it's opposite of the longest side, it must be the largest angle in this triangle. So angle J would be the largest angle. Our next largest angle would be across the next largest side. So here's our next largest side, EJ. The angle across from that is angle C. So angle C would be a little bit smaller than angle J. And then our shortest side is CJ, and our angle across from that would be angle E. So that has to be our smallest angle in the triangle. This is our theorem regarding the measures of angles. Even though it's called the longer side theorem, it gives us information about the angle measures in a triangle. With the knowledge of our longer side theorem, we can now order the measures of angles in any triangle when we know the side lengths. We can go smallest to largest, largest to smallest. In this example, we're going to order the angles in an inequality from largest to smallest. So again, the way we do this is by identifying the longest side. In this triangle, the longest side is side AC. The angle across from that is going to be the one that relates to it. So that's angle B. So because that's the longest side, this must be the largest angle. So if we're going from largest to smallest, we must start with angle B. That's going to be the largest angle in the triangle. Our next largest side is side BC. The angle that relates to, the angle across from it, is angle A. So again, we knew B had to be the largest angle, so what we're going to do now is say that that is greater than our next largest angle, which would be angle A. And I'm only changing the colors here so that you can see, because sometimes with these angle symbols it looks weird with those greater than and less than signs involved. And then lastly, we have our smallest side, AB. The angle that relates to is C across from it. So that's the smallest angle. So these angles are going to be larger than that. So again, this angle A would be greater than our smallest angle here, which would be angle C. Notice in this one, we are arranging from smallest to largest this time, instead of largest to smallest. So let's be careful, make sure we're reading directions at all times. So our smallest side now is side AB. The angle that relates to is angle C. And I'm just going to do this. This is just a way that you can visually work through this. I can just say, okay, I can put S here. That's the smallest angle. Okay. Then we have like our in between, our medium side is BC. The angle across from that is angle A. So that's my medium angle. And then my longest side is side AC. The angle that relates to is angle B. Across from it, that would be the largest angle. So if I want to order these, I'm going to small, medium, large. So angle C is the smallest. And so that means angle C is less than our next measure, which is angle A, which would then be less than the measure of our largest angle, which is angle B. That is smallest to largest for this triangle. All right, I love this example here. We have no figure given to us, but we're going to have to do this arranging this inequality of angles when we know that there is an isosceles triangle where angle B is the vertex angle, and we're given the length of two sides. So we should draw this based off of our knowledge of isosceles triangles. So I'm going to draw a triangle, and I'm going to give it two congruent sides because I know that isosceles triangles have two congruent sides. It's something that you should know as well. You should memorize it. The vertex angle is where those congruent sides meet each other, which is this one up here. So if B is the vertex angle, then I need to label that point as B up top, and then therefore my other 2 points can be A and C for this triangle ABC. We're told AB is 10. And remember, they have two congruent sides. AB and BC are congruent to each other. So if AB is 10, then BC must also be 10. And then we're told that AC is 4. Right? And then from this, we can now determine the measure of our angles. Now, make sure that you understand this point. If there are two congruent sides, there must also be two congruent angles. So what we can determine with this is what our smallest angle can be, what our largest angle can be, and in our inequality, we're going to have equal signs in it, in addition to a greater than or less than sign. All right, for example, what sticks out to me when I look at this is that this side that's not congruent 4 is the smallest side of the triangle. So side AC sticks out to me as the smallest side of this triangle, so the angle across from it, angle B, would therefore be the smallest angle of this triangle. So I could start my inequality by saying that angle B is my smallest, so it must be less than all the other angles that are in the triangle. But again, the idea from here is knowing that if I have two congruent sides, the other two angles in here must be equal to each other, but also combining that now with knowing that 10 is larger than 4. So these angles that are across from the 10s, that would be angle A and angle C, are greater than angle B because 10 is larger than 4 for our sides. Okay, but they're equal to each other, angle A and C. So angle B, our smallest angle, is less than, and I'm just going to pick one of these because they're the same value. It doesn't matter which one comes first. Let me change this less than sign to red so we don't get it confused. So let's say angle A. But from there, angle A is equal to angle C. Right? This would be an inequality to represent the angles in this triangle. I know angle B is the smallest because it's across from the smallest side. My other two angles, though, are equal because they're across from equal sides. So B is less than angle A, but angle A is equal to angle C. That's our inequality for this one. We are now going to learn essentially the converse of the longer side theorem with our longer angle theorem. So now if we know the angle measures of a triangle, we can take our same knowledge that we've learned here to determine what our longest side would be or what our shortest side would be. So if one angle of one triangle is larger than another, then the side opposite of that large angle has to be greater than or longer than the side across from the smaller angle. All right, let's take a look at how that works. Here's a triangle with three angles known. We have an inequality written. Angle C is the largest angle, therefore it's greater than angle A, which is the next largest, therefore greater than angle B, which is the smallest. We can also now determine, though, the order of the sides from largest to smallest, right? Their same relationship. Any given angle relates to the side across from it. So our largest angle is across from the longest side. AB is across from angle C, therefore AB would be the longest side of this triangle. Again, we can think of that as saying like that's the longest side. Our next biggest angle is the 60 degrees. That's across from side BC, so that'd be like my medium side. That's my next biggest. All right, and then my smallest angle is the 50 degrees. That'd be across from my smallest side, all right, which is side AC. So largest side across from the largest angle, therefore is greater than the next biggest side, greater than the smallest side. It's an inequality here for this example. We're going to be applying this now on our own and writing our own inequalities for side lengths in triangles. We're going largest to smallest in this example when we start by identifying our largest angle, which is angle N. So across from that, 82 degrees would be our largest side. Our next biggest angle is the 56 degrees, so across from that would be our medium side. Our smallest angle is the 42 degrees, across from that would be our smallest side, and we can now write an inequality from largest to smallest. So my largest was LM, therefore that's greater than my next largest, which is MN, which would therefore be greater than my smallest, which is LN. That's our inequality in this example. In our next example, we're going to go smallest to largest, with one little caveat here that we don't know the measure of our third angle, which is fine. We can just draw on our prior knowledge of the triangle sum theorem. We know the three angles in any triangle must add up to 180 degrees. So x plus 80 plus 45 equals 180. We can combine these like terms here. 80 plus 45 gives me 125. We can subtract that 125 from both sides, and we determine that that missing angle is 55 degrees. I'm gonna go ahead and write that there in our figure, and now we know the measure of every angle. We can order our sides. Our largest is the 80, so the side across from that would be my large side. My next biggest is the 55, across from that would be my medium side. Our smallest angle is the 45, across from that would be my small side. And again, we're going smallest to largest in this example. So smallest side, AC. Because it's the smallest, it would be less than my next biggest side, which is AB, which would be less than my largest side, which is BC. There's the inequality for this example. All right, we have here another example with no figure drawn for us. We're told RST is an equilateral triangle. We're asked to write an inequality for the side lengths here. I'm gonna go ahead and draw a triangle RST. It doesn't matter where we put the vertices on this one, because in an equilateral triangle, we have to recall that all the sides are congruent. They're all equal to each other. So technically we cannot write an inequality because we have equal sides here. We would have RS equal to ST and equal to RT. For an equilateral triangle, all the sides are the same length. So we've learned how to write inequalities that order either sides or angles from largest to smallest or smallest to largest. We're going to be adding some calculations to our inequalities now. We're specifically going to be learning the triangle inequality theorem, which tells us how triangles are possible. It essentially tells us if a triangle can exist or not by giving us a rule for the inequalities for the lengths of sides in triangles. So here's the rule that we need to memorize. The sum of any two sides in a triangle must be, it has to be, greater than the third side of the triangle. If this inequality is not true, then a triangle cannot exist. If you take the length of any two sides of a triangle and add them up, they must be greater than the length of the third side. Here's an example without using numbers. Notice here, we're taking two sides like A and B and adding them. Whatever those values are, they would have to be greater than C, right? The same thing is true of any two sides. If I add A and C together, they have to be greater than B. If I add C and B together, it has to be greater than A. This must happen in order for triangles to be formed. If these inequalities are not true for any three numbers, they cannot make a triangle. We need to be able to tell, can we make a triangle with any given side lengths? And again, the rule is any two sides we add together must be greater than the third side of the triangle. So if I take two sides at a time, like 11 and 23, I need to confirm that that is greater than 30, the third side. 11 plus 23 is 34. 34 is greater than 30. I'm just making a little note here. That works for those two sides. But again, it's any two sides here. So if I add 23 and 30, that has to be greater than 11. We just need to confirm that that's true. 23 plus 30 is 53, which is indeed greater than 11. That works. And again, any two sides. So if I add 11 and 30, that needs to be greater than the third side, 23. 11 plus 30 gives me 41. 41 is greater than 23. That gives me a possibility for a triangle because any two sides I add together end up being larger than the third side. So yes, this can make a triangle. This wasn't really worded as a yes or no question, but that's what I'm gonna put here for my answer. Yes, those three side lengths can make a triangle. Notice now, before we move on though, only one of these calculations I've done is really important. And it's the one where I add the two smallest sides together. Hopefully it makes sense to you. If I'm adding the largest side of a triangle to any other side that's given, it has to be bigger than a side that's smaller than the largest side, right? Like 30 is already greater than 11. So I know that's gonna work out when I add those two sides. Again, 30 is already greater than 23. I know that's going to work out. The inequality that matters is the one where we see if the smallest sides are going to be larger than the largest side of the triangle. So this is really the only inequality we have to evaluate to answer a question like that. Add the two smallest sides together, determine if they're larger than the longest side. Let's do that here in this example. Let's take our two smallest given lengths, add them, and evaluate them compared to the longest side of the triangle. Again, our theorem tells us when we take those two smaller values and add them together, get the sum of those numbers, they must be greater than 58. So I'm evaluating the truth of this inequality. 21 plus 37 is 58, and 58 is not greater than 58. Therefore, these lengths cannot make a triangle. All right, this is not a triangle. Those side lengths do not work. Now that we know the rules that our side lengths have to follow, we can use inequalities to determine a range of measurements for an unknown side of a triangle. So if I have two sides given to me, I can figure out a range for a missing side. The way that I would do that is by both adding and subtracting the values of my given sides, right? Let's see how this works in practice. So I have an example here. I have a triangle with two known sides, 14 and 9, and I'm being asked to describe the possible lengths of an unknown side, of the third side of this triangle. Like I've shared, we're first going to add these known values together. So 14 plus 9 gives me 23, and 23 represents my upper limit. This unknown third side cannot be this high. Let me explain why. This would give us side lengths of 14, 9, and 23. Let's see how that inequality would work. We know the two shortest, the 14 and the 9, would have to be greater than the longest side, 23. And we can see this inequality doesn't work because 14 plus 9 is 23, which is not greater than 23. However, if we have a side length that is smaller than 23 for our third side, we would see that this does work. For example, 22 is smaller than 23. 14 plus 9 is 23, which is greater than 22. So that triangle is possible. So we cannot be as high as 23, but if we're below it, we're safe. Now let's look at the other calculation we need to do. We need to take those known sides now and subtract them. We're not going to do 9 minus 14 though, because I don't want a negative number here. We need positive values. So we have to do the big side length minus the small one. So 14 minus 9 gives me 5, and that represents my low end. I cannot be that small. Again, let's see why. I have 9, 14, and a theoretical 5. That gives me 5 and 9 as my smallest sides, and we know those would have to add up to be larger than the biggest side, which is 14. And again, we see this inequality doesn't work. 5 plus 9 is 14. That's not greater than 14. That cannot make a triangle. However, if we're larger than 5, for example, if we are 6, we would be at a larger value. 6 plus 9 gives me 15, which is greater than 14. So these calculations have given us our limits. I cannot be as large as 23, and I cannot be as short as 5. Our range of values is in between, and we're going to write this as an inequality. So we have two options. We can say less than 23. We'll use x to represent our third side here. So we could say x has to be less than 23, and we need to be greater than 5. So we can say and x needs to be greater than 5. What I prefer though is to write that all in one inequality, and that would look like this. 5 has to be less than x, or third side, which has to be less than 23. That inequality says all this stuff in one. We need to be greater than 5, less than 23. Okay, let's see if you can do this on your own. Remember, we're going to take our two known side lengths, we're going to add them and subtract them. Those are going to represent our limits, and then we're going to write accurate inequalities for the possible length of the third side of this triangle. Go ahead and pause the video, try it on your own. All right, let's see how you did. We're taking our two known sides, 43 and 21. We're going to add them together. 43 plus 21 gives me 64. That represents my upper limit. I cannot be that high. We're going to take the same known sides and we're going to subtract them. 43 minus 21 gives me 22. That represents my lower limit. I cannot be that short for this third side. It has to be everywhere in between. Again, this is the way that I like writing this inequality. This right here, that part says our third side has to be greater than 22. And then this back half of it says, but it has to be less than 64, right? That inequality works here. You could also say though that x needs to be greater than 22 and x needs to be less than 64 in separate inequalities. That is also true. I just like writing it as one. Guys, that wraps up our lesson on inequalities in one triangle. We'll see you in the next one where we talk about inequalities in two triangles. Bye guys.